Hello and welcome to Crazy Math Productions. Today we're going to do an extension of the 6-4 Part B video where we're going to look at how some of these different parts in the absolute value equation actually affect the graphed form of the solution set. So what we're going to do, we're going to go ahead and ask a series of questions here. First of all, how can you predict whether the graph opens upward or downward? So I'm going to go ahead and just give a sample equation based on this. So we have y equals 1/3 times the absolute value of x minus 3 plus 4. So in this sample, what we're going to say is, whatever comes out of this, the absolute value, forget whatever's in here. We're just going to ignore this completely. I have no idea what's in there. Whatever's going to be in there is going to be either positive or 0. So if I multiply a positive by a positive, I end up with a positive. If I multiply 0 by a positive, I end up with 0. So that's only going to give me more positive results, or 0. So that's going to make this upward. Now, if I make it a negative, the opposite is going to be true. A positive times a negative is going to be more negative, and 0 times negative, of course, is still 0. So that's going to tell this right here, A, is going to control whether it's upward or downward. So if A is positive, the graph opens upward. If A is negative, the graph opens downward. All right, let's look at another one. How can you predict whether the graph is skinny or fat? I'm actually going to go back to this original one that wrong button. This original one that we've looked at. Basically, y equals 1/3 absolute value of x minus 3 plus 4. What's happening is, whether you realize it or not, when you're going to graph this, of course we're looking at these, if you will, this number here, A, is going to give me the slope of the right-hand V. And I'm going to take the opposite of that to find the slope of the other half of the V. So the slope of this one would be -1/3. Slope of this one is +1/3. So how can you predict whether the graph is skinny or fat? Well, I'm realizing that I probably should have typed the last response. Here's the deal. If A is between 0 and 1, then the graph is going to be fat. In other words, it's going to be lower to the graph. So in this case, 1/3, comparatively speaking, it's going to be fat or lower profile here, because that's this 1/3 you would rise 1 and run 3. So that's going to affect that, because this is telling me the slope of the right-hand part of the V. Now, that is actually the absolute value of A, so I really need to adjust that. Okay, and we can also talk about that if the absolute value of A is larger than 1, then the graph is going to be skinny. And the reason being that, again, this A number that we had referred to up here, if A is, say, 3, let's change this so y equals 3 on the absolute value of x minus 3 plus 4. What that's going to do is to change my slope to 3 over 1, rise 3, run 1. So I start with my vertex, rise 3, run 1, and that's going to make my graph much skinnier. This is going to make it fatter or lower profile, and this one's going to be rising much quicker because the slope is much higher. Now, of course, this could be a negative 3, and it will do the exact opposite. It's going to go down much quicker. So we do talk about the absolute value being larger than 1. Okay, find a shortcut for determining the x-coordinate of the vertex. Well, if you haven't figured this out already, A actually has no bearing on the vertex, because what we're trying to do is to find out exactly where this part, the absolute value, is equal to 0. So generally speaking, what we've been doing is to set x plus b equal to 0 and solve for x. So you would naturally subtract or add the opposite of b, and x equals the opposite of b. So that's going to be the x-coordinate of my vertex, always. Whatever b is, the vertex x-coordinate is going to be the opposite of b. Then you're going to plug that back in. Well, the opposite of b plus b is 0. The absolute value of 0 is 0 times a is still 0, then plus c. So the y-coordinate of the vertex, of course, x, y, the x-coordinate is always going to be the opposite of whatever b is, and the y-coordinate is always going to be c, just straight up. So when you're talking about finding a shortcut, the x-coordinate of the vertex is the opposite of b. Find a shortcut for determining the y-coordinate. It is c, always. And number 5, compare the graphs. Let's actually get out a graph. Okay, now, again, several things here. Number 1, let me rewrite this in the following way. Y equals 1 over 1 times the absolute value of x minus 0 plus 0. Well, where in the world am I getting the 1 over 1? I'm just putting that in there so I could see a number here. Where am I getting the minus 0? Again, just putting something there so I can see a number. Where am I getting the plus 0 at the end? I'm putting that in so I can see a number. So what I'm going to do is use some shortcuts here. The opposite of this is 0. Use this is 0. That's my vertex. 0, 0. Then for the right-hand side, from here into the right, I'm going to use this as my slope. Rise 1, run 1. Rise 1, run 1. Continue that for a little bit. And then I'm going to flip that and say negative 1 over 1, right, excuse me, rise 1, run negative 1 for the left-hand side of the vertex. So that's going to give me the graph, y equals x. Now all I'm going to change here is this number here. Well, this number is telling me, it's talking about where the vertex starts. The slope is still going to be the same, but we're going to change this part. Well, remember, for me to find the vertex of this, I set x plus 1 equal to 0. So subtract 1, x equals negative 1. So now the vertex is going to be negative 1, 0 instead of 0, 0. So how does it affect it? Well, I'm going to put this one in, let's say I did this one in black. Let's do this one in red. Everything's the same except that now my vertex is at negative 1, 0. As you can tell, all that has happened is I've shifted the graph 1 unit to the left. Let's work in green for this one. As you could predict, when I set my x minus 1 equals 0 to start the vertex, finding the vertex, x minus 1 equals 0. I'm going to add 1 to both sides. X equals positive 1. Plug it back in, we get a 0. So the vertex of this one is going to be 1, 0. Well, as you can predict, all that's going to happen is for me to shift that graph to the right. So compare these graphs. Y equals absolute value of x. This one's been shifted 1 to the left, and this one's been shifted 1 to the right. Let's do the same thing for this. I'm actually going to use what we had done here. Now again, let's call this one the black version, and this one the red version, and this one the green version. Now, as you could assume, since these deal with the horizontal displacement of the original y equals absolute value of x family, this deals with the vertical displacement. So when I do absolute value of x plus 1, it's literally going to move all the values up. When I deal with the green one, it's literally going to move all the values down. And so you can see, even though the red has been very poorly graphed, and the green really too, since I didn't use my vertical line tool, or my straight line tool, you can see that the same thing has happened. The red here has moved it up 1, and the green one has moved it down 1. Okay, that'll do it for the lesson today. Thank you for listening to Crazy Math Productions.